Okay, it is not completed, but I will show you as maximum as possible, right? What I have done. Okay. So the visualization part is not completed, and I will start first the nifi things, like how the nifi is integrated in this use case. So I will give this link so you can understand the architecture part of this POC. So what are the components are used? I will explain it brief. Okay, so that because it's already needs a hands-on before like starting any POC, right? We should know exactly like what we are going to develop, right? So we should know Hive or the other tools and components, right? So we should have knowledge before, right? Because this one is using real-time analytics, right? So real-time analytics using the NiFi, PySpark, Hive, SDFS, Kafka, Airflow, Tableau, and QuickSight. So there are this is complete ETL data pipeline, and ETL data pipeline is having three layers, right? Ingestion layer, transform layer, and we have the final data loading. Okay. So then and visualization layer, after once the data is in the target data store, then we can have the visualization. And this entire pipeline is scheduled through Airflow. So here, Airflow is not complete pipeline is scheduled. What I have done, just a simple use case to write the data into Hive. Once my data is on the SDFS is there, then it will be loading data into Hive. But we can do entire pipeline also. We can schedule it through Airflow. Even the Spark job can also run. Okay. Okay, so when we starting this use case, this is the API. This is a Corona API, right? Okay, so there is a URL. This COVID API. Okay, so covidapi.com. This API is now converted into this. Okay, but it will be showing me here access issue. But when I'm going to read this API through nifi, okay, or some postman, then you will get the data. Okay. So this API is having the data. Its data looks like this. So the data is in this API, and this data is continuously coming. Okay. So this data is the corona, right? Number of death cases or total cases, new death. So you are already aware of that country-wise data, right? So this country-wise data is there, okay, and this data we are analyzing, okay. So we are using nifi for the ingestion, okay. So so nifi we are using as an ingestion tool here. So nifi is ingestion here. So initially, this is just API is here. Okay, this is the API. This is some REST services exposed. Okay, on the internet. Okay, and we are using HTTP invoker. Okay, I will talk about little bit about the nifi. There are the processors are there in the nifi. Okay, and those processors like we can configure it to get the data from the source or write the data to the target. So we can configure. So there is a HTTP invoker is there. So this HTTP invoker is reading data from this API endpoint and ingesting data. Okay, and in the nifi there are many more operations they are doing. Um, so we can do those operations like splitting the data, it is JSON data. So it's a complex JSON is there. It's a nested JSON is there. So in the nested JSON, like you will be seeing some array. So arrays data will be there like a square bracket array. You can see like this one, like, okay. So this kind of data, we can split it into the, like we can flatten the data. Okay. And then we have some encryption things. There are a lot of things are happening in the nifi. So I have not used those things. So I have just changed little bit nifi pipeline. Just simply read the data from any endpoint. We are reading data, and then I'm writing the data to the SDFS, and then write the data to the Kafka. And there is a Spark job, which is reading data from the Kafka. And this Spark job is reading data from the Kafka and writing through the data to the another Kafka topic. And this Kafka topic, again, nifi comes in picture and read the data using the consume Kafka processor. And then another processor is there in the nifi put SDFS, that is writing to the SDFS. Okay, from the Kafka to SDFS. And once the data comes in SDFS, the process data. So initially we have the raw data. So here is the data which is coming from the API. It is a raw data, and we are transforming this data and writing to the data to the Kafka topic, and then consume Kafka is the processor which is reading data and then finally writing data to the SDFS. And then Airflow job is running, which is writing data to the SDFS2 table, Hive table. And once the data comes in the Hive table, then query the data, and then we can do the visualization in the QuickSight or Tableau. Okay, so this is an entire process flow. Okay, so I will show the pipeline they have given they have given the nifi flow, but I have removed some of the nifi component. Okay, because those are not properly running, but I will show you what I have changed it. Okay. Okay. First, uh, how to do the nifi setup. Okay. So this is my AWS EC2. Okay. So in the EC2 console, I have created a one machine, Amazon Linux 2. Okay. So, so I'm starting the instance. So you can simply launch it here. Okay, I just show you once that how to launch the instance. For this particular use case, we need a good amount of disk storage. Okay, okay. If we see the configuration, this is the configuration of the this pipeline. So what are the components we are? Okay, so for this one, we have to use the Amazon Linux 2 AMI, and it should be a T2X large, and storage capacity, you keep it this one. Otherwise, you will get the disk storage issue, right? If you took, if you take like T2 micro, mini, or medium, right? So you will get the disk storage issue. Okay, so take it this much of storage, right? So that you can because we are all everything we are installing on the EC2 instance. So there is another way of this is the Docker. We are going to use the Docker commands to set up this entire pipeline infrastructure in using the Docker containers. Okay, but there is another way is there. We can go for the manual installation. Okay, so if we have on the Ubuntu, we have this Hive is there, Hadoop is there, Spark is there, Kafka is there, we have Airflow is there, nifi is there. So everything we can install manually. Okay. So once you do all this setup, right? So this setup, if I say why we are going for Docker, right? The question comes like why we are going to use the containers. If I say, if you want to install all these things, you will take approximate 5 hours. Okay. And the same thing, if you are going to use the Docker, I will give you the compose YML file. So there is a one compose, Docker compose YML file. There, all the configuration of these all tools are defined. Okay, everything is given there. If you once install your Docker, first you install Docker, and then you install Docker compose. And then after, if you run the Docker compose, if you run Docker compose, then you will see, you will get the containers. So you will get around 10 containers. 10 containers will be there. So these all containers will be there. Kafka will be there. Zookeeper will be there. So all 10 containers will be keep running. Okay. So 10 containers will be running, and these containers will be set up within 3 minutes. So 5 hours things you are setting up, right? Manual installation, but in the containers you are setting up this cluster 3 minutes. So 3 minutes you will set it up. Okay. And this is like, if you this complete environment, you push in the Docker Hub repository, push Docker Hub repository as a image, Docker Hub repository. So then anyone can get the same setup from your image and create a containers. So this is the advantage of using the Docker, because Docker is lightweight. Docker is lightweight. And the second thing is, it is not taking time to start. It is not taking time to start. And whatever modification in your infrastructure you are doing, modification you are doing in infrastructure, so you can update, in your custom image, you can update in your custom image, right? So again, it will be saved, and then you can pull up anywhere the updated infrastructure. Okay. And if you are following this approach, so this approach is basically in the virtual box and Ubuntu, you are installing manually, and you have to do setup your own. Okay. So the main infrastructure development takes more time in this approach, and the Docker approach is lightweight, and everything is done by the Docker itself. So just we have to uh, do this application development. So our focus is to not the mainly develop the infrastructure, development of application. Okay. So development of application will be more emphasized, right, for a developer, right? Or more emphasize for a developer. Okay. So this way we can use so both the approaches are there. So if configurations files, everything will remain same. Okay, like, okay, whatever I need like Hive script, I need HQL scripts are there, right? Some, okay. And I have apart from the like I have a PySpark job, right? So this all code will work same as whether you doing uh, Docker kind of approach. And further, if we like more override is there in Docker, like, okay, we can go for Kubernetes. So whatever this infrastructures, like manually, I'm creating this Docker compose file. So if we go for Kubernetes ham, so Kubernetes ham is the repositories are there. Okay. So some official repositories are there for all these components. Okay. Just we have to import, or we have to create. So ham is basically providing a package manager, right? You can get those official repository in your local, and then doing the setup, right? So even this Docker Compose you will be avoid. Okay. And this ham will be giving a more control over like a infrastructure. So here you are getting 10 different containers. So suppose I say I have to write a SQL queries. Okay. So I have to go to in the Hive container, because all these containers are separate containers. So I have to go to Hive container, start Hive shell, and then run the SQL query. Okay. Suppose I say I have to create a Kafka topic. Okay. So I have to go to Kafka container, and there I have to do setup, right? I have to create a Kafka topic. Okay. Kafka topic. So, and if I say, if I want to use nifi configuration, so I have to go to like any container you have to go. So here is the everything is in the one single cluster is there in the Kubernetes. Okay. So every here is also the concept of container is there, but you are not managing manually here, right? Okay. So that is more extra advanced concept. Okay. Even I have not implemented, I'm in progress of that. Okay. So once I will be having the Kubernetes ham related infrastructure implemented, then I will show that. Okay. So we come to here, and I want to create my Linux instance. So I can simply create any instance here. Okay. So I can create Linux instance and Amazon Linux. Okay. And here I can choose T2X large. So T2X large, you can choose this instance. Then you can select your key pair. If you don't have key pair, you can create key pair, and you can select the key pair. And here, when you are giving the storage, right? So this storage, you increase it. Okay. So whatever is storage, like I told 96. So this much minimum storage you take it, because it is really required, because a lot of installation is needed. Okay, so once this instance is created, so your instance will be look like this, and it is running. And now I have to connect this instance. Okay, I'm using a git bash. So I will find my connection URL, SSH connection URL. So I will get it connection SSH URL. Okay, I will use my connection URL. So git bash. So git bash, we will be connecting to connect our EC2 machine. CD down. So I'm connecting. Okay. So I connected Amazon Linux. Okay. So first of all, here, please. Okay. So here I created folder Docker exp. Okay. So if we go to, okay. So there is a how to transfer the data in this one, bin SAP. Will connect to bin SAP. So my host is, this is my public IP. Select this, and the user is a EC2 user. There is no password. Go to advanced authentication. Okay. So login. So first what you do, I have the this folder. I will provide all the artifact, right? What are the things is there required to execute. This complete folder is already prepared. Okay. So here in this folder, when we are going to do the setup through the Docker, we need Airflow initialization file is there. This Docker Compose, we will run it when we were all infrastructure is done, then we will run this Docker Compose. But before that, we need a Hadoop environment. So those are the configuration files we needed. Okay. So I have copied this everything here from, and this document also there. So you can get the document here, config doc. Okay, so this doc, which I'm following it here, this document. Okay, so this document you can get it there. Okay, so so first of all, I copied this exactly the same, but here you will see this plugin logs, or these folders will be creating when we will be doing the setup, right? Okay. So some steps we have to follow. First of all, we will copy this Docker exp folder to our EC2 instance. Okay. So that I have done. Okay. So that I have done. Next is, okay. So next what to do. So let's verify the steps. Okay, so these are the commands. Okay, leave this one. The first thing is this part is done. Okay, this is done. Okay, connect to EC2. This one we done. Okay, so we are already in the our EC2 instance. We are done. Okay, now Docker install. So this command I have already run. Okay, like sudo yum docker. So mine is already like already done this one. But if you follow this in the EC2, this will install your Docker and Docker Compose. So two things it will install. Yeah, it's already mentioned here. Docker and Docker Compose. So it will install two things, Docker and Docker Compose. So I want to see the version. The Docker Compose version is coming. If I see Docker version, okay, how to change the font. Okay, so Docker and Docker Compose is done. So this part is done. Okay, this is just an installation of Docker, because without this, we cannot run the Compose YML. Next thing is copy the files. They have used SCP command, but we have done with the WinSCP. Okay, so we have done through WinSCP. So either you can do with the WinSCP, you can do with the WinSCP, or we can do with WinSCP. Okay, so we can do. And next is I have given the permissions, because initially you will get the not write and execute permission will not be there. So I have given entire folder my write execute permissions I have given. Okay, so that permission I given. Okay, so this is done. Okay, next is I have to go to the Docker exp folder. Okay, so cd. Okay, we are already in this. Okay, I'm already in this Docker exp. Okay, and here the next installation is airflow init.sh. So airflow.init.sh when you run, okay. So mine is already file created. Still it is doing. So everything is already set. Okay. So this airflow init.sh. Okay, what is this file? Okay, let's see. Airflow init.sh. This is Docker Compose up airflow init. So another Docker Compose up airflow init. Okay. So this is completely doing the airflow initialization. Okay. The airflow init is a command for the installing airflow. Okay. Mm. So actual airflow will be installed with the Docker only, with the Docker airflow image. But before installing the image, right, we should do some initialization of the configuration. So that we did airflow init. But after that, we need this plugin and the DAX folder, logs folder, so which already we have created. Okay, with this airflow init. Okay, so after this airflow init script you run. Okay, once we done, then we are moving the script of this Hive script or Hive connection script for the airflow. This part we will do later also, because we are not we concerned about the airflow. Okay, so our main concern is first is Hadoop, Spark, Kafka, okay, and nifi. So these containers we have to run. Okay, so Docker Compose up command we will run in the place where my Docker Compose file is there. Okay, so I'm running my Docker Compose up. Okay, so mine is already containers previously installed, so it will not take much time, because this is all containers will be coming. After this, we'll get all the containers. Okay, so I will open another git bash. So these many containers will come. Here's the problem. Take it correct URL. This IP and this IP. This is the old one. Yeah. Because whenever you stop and start the instance, so your IP will change. So just make sure. So here now I will do Docker PS command. Okay. So now Docker PS command, you will see now all the containers are, when I do Docker PS. So you will see here all the containers are running. Here is a Postgres Metastore database. This is used for the Airflow. Okay, because Airflow is using its own metadata to store. So there is a Postgres is a database, internal database store. And the Spark container, this is Hadoop Spark container. Okay. And this is a image, Airflow image, and okay, Hadoop name node. This is a Hadoop name node is there, Hadoop data node is there. Okay, and Presto DB is there, nifi. This is nifi is there, Zookeeper is there. Okay, so these are the containers are there. Okay, so next thing is, so this part we done. Next is a port forwarding we have to do. So Docker is giving its container port, but those container port you cannot access outside the container. So whatever is there in the container, you can't access the outside. So suppose you have to access the URL outside the container, right? So you have to do port forwarding. So port forwarding we do whatever our this SSH connection URL. Okay, so I make another get bash URL, and there I will do the port forwarding. Okay, so when we log in to the EC2 instance, so this is my URL. And here I will see what are the ports we have forwarded. Okay, so here are the different, like this is a Zookeeper port is there. This is a Hadoop ports are there, 575, 570. Okay, so this port from the internal container to outside container, 10,000 port is for the beeline Hive server is there. Okay, so these are the port forwarding. So we will copy from here is -O, and then we paste it here. So it will start. Now this container, this particular login is having already port forwarding is done. Okay. Now we can see these URLs. Okay. First we start with the Airflow. No, this nifi. So nifi is this port. Okay. So I will open the nifi. So this is the nifi interface. Okay. So when you see this is a canvas, this is a nifi canvas. So here are the different options are there. Okay, there are the different options are there, processors are there, import port, output port, or we have processor group, right? If more than one processor is there, I want to grouping those processor, I can do the using the processor group. And there are other things also there, but we have to use template. So they already provided template. Okay, first I show their template and then I will show my template, okay, which I modify. Okay, so how to add the template? So we can select the template here. And so template is nothing but XML file, and there once you import the template, everything you will get it in your canvas. Okay, so you don't need to redesign. Okay, so you don't need to redesign. One more template. Yeah, this template, nifi forward. So once we upload the template, then we can drag it here, then select the template. Already it's coming selected. So this is the entire flow. Okay. So what this flow is doing, so there is one flow file is there. It is starting point. Okay. So generate flow file, and this is HTTP invoker. Okay. So this HTTP now this time is all the component in this nifi is stopped. Okay. If you want to start anything, we can start right click and then we can start it. Okay. We can configure and we can or we can start. Okay. So configure, we can go to configure and see the properties. So if I see the properties, this is the API property. Okay. But this property, this API is not currently running. So what the change in this API is, this is a COVID-19 API.com. This API dot is removed. Okay. And that one is working. Okay. So this API URL is here, and here are the other properties. Some other default properties already there. We don't need to change, but we have to specify whether we want to get request, post, what request is there. So HTTP method. HTTP method is a default method is there get. Okay. And nothing to change here. But whenever we are joining two component, right? One is a generate flow file and the HTTP invoker. So we have to set the success failure. So every component in the nifi is like the data is flowing from one component to another component. So there is a queue is there. So data is flowing through the queue. And when this queue is populated, you can see the data, what data is there in the queue, and you can completely control the flow because you can stop any component at any time. Okay, because it's a like a streaming kind of automated pipeline where the data will keep flowing, but wherever you want to control, you can control the flow. You can stop the this component, so further nothing will flow. Okay, so we can easily debug our issue, right? Suppose I got the issue. Once I get the data through HTTP invoker, I'm giving the this processor. This processor is basically reading your JSON data and splitting the JSON data. There is a split JSON processor is there, and this split JSON after doing this, then again I'm getting the JSON. Okay, so I'm getting the JSON data. Okay, and then I'm updating any attribute. I'm updating in attribute. I'm encrypting, and then I'm making it uppercase, and then I'm applying some hash, some unique key, and this is another nifi flow, right? So this, when I go inside this, so this is completely another new flow. This is another big new flow, and that is doing a lot of processing things. So this processing, I can do it in the Spark itself, but suppose I want to do it with the nifi, so nifi can do, so I don't need to write, because nifi has already provided these many component is provided, right, for the different things purpose, like updating attributes. Suppose you want to replace some particular text, so you can have some regex expression, you can replace the text. Okay. And this thing you can do, replace text, extract text, like suppose you want to extract the text from your record, right? So how can you do? So you have to define some pattern. Basically each and every processor, we need to understand there are around 250 processors are there, and now the processors are for the cloud also there. Like you can even read and write data to the cloud services also. Okay. So execute a script, like some shell script is there and you want to execute that script, so you can keep it in the flow. So this is, and everything has the success and failure. So success, you are moving to the one component, and failure you are going to finally error, right? So error is a final destination where is all the errors you are accumulating. So you can redirecting the error to the error node. Okay. So, and I'm showing you now what I have done, that one. Okay, I made it very simple one, because I'm just reading data from the API and writing data to the SDFS, and then reading from the Spark, and whatever this processing things we can do in the Spark. Okay, because if somebody who is not well good in the nifi, he can use the Spark. Okay, just nifi we can use for the ingesting data, and using the minimal configuration in the nifi. Okay.
So Arvind, if I want to add any component, right, like
Mhm.
replace text, so can we add it in the designer side, or we need to drag and drop over there in the
Yeah, this is designer only. You just drag
Mm.
and drop processor. First you find the processor. Okay. First you drag here processor. Okay. Replace tags. It will be here. And wherever, suppose you want to add one more extra, right? Suppose your requirement comes, replace tags you want to do immediately once you get the data from the API. Okay. So you can add there. And just
Oh, okay.
just you have to add the arrows, right? Like it's just like a, it's just a pipeline is there. Like any middle component you want to make it flow in some other direction, right? So you need to
Yeah,
do
right.
some connector, right? Like you have to add some connector, and then connector means like the queue you have to add. So once this queue you will be attaching with someone, okay, and then attaching the in the destination side, source and destination. So this component will be the part of the pipeline. Okay. Otherwise, if
Okay,
I
fine.
keep it like this is isolated. There is no point of this. Okay. It is
Right. Yeah.
showing here clearly you have not defined relationship. So relationship success or upstream. So this is showing error. If it is triangle is there, so it means your component is not ready. So once this component is attached in the pipeline, then you will be having a flow, right? So anything you can add. So and you can create this pipeline, like suppose you done some changes, then you can do create template. You can create your new template, say my new template. Okay. And this template will be created, and then you can download this template as a XML file. Go to the template here. Now new template is coming. So now this template you select, this is downloaded. This template, anyone can take it. So whatever changes you did, right? So this change, that those changes will be coming to that person, nifi. Okay. So that is an easy way, right? Like this is a simple XML, which is defining the all the component in the form of XML. Okay, like this. Okay. So this is not easy to understand. but I can say what are the high level components are there, right? Connections, these are the connections, but some component level, right? Put SDFS. Type of processors. So like a type of process, it should be there. SDFS. Okay. This one is another part of, this is not the main nifi one. Okay, this is not the main one. Okay, this is the inner one, right? Okay, so that is the reason here SDFS is not there. Okay. Okay, you can do that way. Okay, you can do. Okay.
Okay.
Even I didn't understand this flow. I was trying to run this one. So my data is just coming to the HTTP invoker one, all this one. Okay. But the rest of the flow is not working. So every component need to check one by one and make it flow ready. So it is just like you are start from the first component, second component, then you have to check entire flow. Then you can make it run all the component together. Okay, but initially you have to start from the top level. Okay, right? How the data, because every configuration or every component configuration you have to check it manually. Okay.
Arvind, I think Vaibhav has a question like why we
Mhm.
choose nifi over the airflow. So what is the
No,
main purpose
airflow
of
is
using?
we cannot compare with that. See, airflow is not having drag and drop things. It's a orchestration tool, right? Basically, especially scheduler. Here is no scheduler. You cannot say, okay, this pipeline will run on this particular time. You can't do this, right? Here, you are design pipeline. Okay, similar thing, airflow we are doing, but airflow is giving one more extra step, right? Like you can schedule your pipeline, okay, and that pipeline will run on a specific time. You can schedule it, right? That you can do. And airflow is not having the drag and drop things, not these many processors, right? Everything you have to write as a Python code manually. So first of all, you should have the knowledge of Python. Here is no programming language, right? If you know the configuration things, how to configure this component, you can develop the entire pipeline within like 30 minutes. But if you are going to do with the airflow, so you can think of how much time it will take, right? You have to write the entire deck file, correct? So anything, something is good there, but not everything is good, right? Okay, so depending on the use case you will use. So nifi is the use case is yeah, if you can say stream set is there, right? So stream set is the, like you can compare, because steam set is a
Yeah.
similar tool, steam set. Okay, but steam set is the main problem is the, like we don't get the proper resources, and like nifi is having many examples on the google, right? So we can easily understand and configure.
So Arvind, this nifi is designed to handle the huge data sets as well, right? So
It
with the
can handle,
Spark kind
right?
of cluster. Mm.
You have to configure it now, how much, like your queues, right? Like your queues, right? What the configuration of the queue, right? Like how much data per second, but it is like streaming kind of data generally, right?
Yeah.
Wait until its connection. It can delete entirely. Okay. Okay, this one I have. So what I did here. So same thing, generate flow file. Okay, and from there we are calling the HTTP invoker, and I'm writing the data put SDFS. And from there, once the data comes on the SDFS, right? And then I'm doing publish Kafka. So my Kafka processor is reading data from SDFS, okay, reading, okay, Kafka. And once the data is on Kafka, there is a Spark job, which is reading data from Kafka topic, that is a streaming job, Kafka Spark streaming job. And that job is writing data to the Kafka topic. Again, the data is coming on the Kafka topic. So separately, this consume Kafka is reading data from the Kafka topic and writing to the SDFS. So this data is my raw data. Okay, I say this is my raw folder is there. Okay, so there I'm storing my initial data, like all the, yeah, Azure Data Factory. Yeah, you can say that it's Azure Data Factory also, same drag and drop. So, and post SDFS, once my data comes on the SDFS, then my Airflow will be reading that. Basically, this SDFS data is a Hive, like some specific folder where I'm writing the process data from this consume Kafka. Okay, so this, because this consume Kafka data is coming from the Spark, right? So Spark will definitely writing a process data, right? And once the data comes on the SDFS, right, and then my Airflow job is writing data to the Hive table. Okay, so that is, and from there is a Tableau or QuickSight is there. So this particular, if I show you what is the URL, I change it. So if I go to the configure here, so if you see here, COVID-19api.com. Okay, so I change the URL, and this URL is taking the data from the REST URL. Okay, and when I say put SDFS, so if you see this configuration of the put SDFS, so I have added this OPT, this Hadoop location, because we need some Hadoop configuration file, because there is a one put file processor is there and put SDFS there. What is the difference? Put SDFS is for storing data into SDFS, and put file is a normal processor, like you can run it in the your Windows environment. Suppose one directory in the C drive and another directory you want to write the data, so you can use the put file. So put file and get file is for writing and reading the files from local. Okay, and put SDFS and get SDFS is basically for reading and writing data from the Hadoop file system. So this Hadoop configuration resources, so I have given the configuration file path. So mainly the two main the XMLs are there. Generally, when we are installing our Hadoop setup, right, manually Hadoop setup, so you will be aware of the core site.xml and SDFS site.xml. So core site XML is a XML configuration file where all the configuration related to map reduce or SDFS related, and SDFS site XML file is having the all the configuration. Okay, so after setting up my this Docker Compose, and I have run my containers, I got it my all containers here. Okay, so here in my Hadoop container is there, and one container is the Spark container is there. So I can check this Hadoop path, I can verify my Hadoop path. Okay, so how to go to the container? For any container you want to go, so Docker exe command is there. So Docker exe command, and this is the container name and the bash. Okay. So if I want to go to the Spark container, so I will do here SDP underscore Spark hyphen master. This is the my container name, and bash is I want to start my terminal as a bash terminal. So I have given the bash. Okay. So I'm going to start first. I'm going to check my Hadoop one. Okay, so this Hadoop container. So now, right now I'm in Hadoop container. I can run here any Hadoop command, Hadoop fs minus ls slash. Okay, so this is my root directory. Okay, so this all folder is created. right? Desired data, right? This, okay. So this one. So I'm removing it. This folder should be created by when I will ingest the data. Okay, because I have already run the application in my same machine. So still the data is there. Okay, so I'm removing it. See, desired data is a first level of folder, like very first hierarchy level. And after that, this Corona table or desired Kafka out, these folders will be created by the processes, right? Suppose initially HTTP invoker data is coming in this Corona table, right? This is a raw data. So this folder will be created by the process, like HTTP invoker will be creating folder and writing data. Okay, because in the HTTP invoker, I talked about what is my target, like SDFS put. Okay, so if I say SDFS put, because I'm reading the data from the HTTP invoker, and here if I see Corona table is there. So desired data is a first level of root level of directory, and inside the root level of directory, I'm defining the Corona table. This Corona table will be taking the data from the REST API, okay, and writing the data as a JSON files. Okay, so I have already data, but I'm removing it. Hadoop fs minus rmr command is a Hadoop command to remove the any Hadoop file system directory. So R is recursive, so that will all the folders and files, everything will be deleted. Okay. And now next is I'm deleting this desire Kafka out also. So I will keep it only one folder. So this folder I will create it, desired data. Okay. So this folder I will create, and rest folders will be created in the this Hadoop file system. Okay. So next is if I want to go to the Spark shell, so I can run my Spark job in the Spark container. If I want to create some Hive tables, okay, so I can go into the container, I can do. Okay. So these are the URL given, like how to access your nifi. Okay. To access data push and Hadoop from the nifi. Okay. So this is, okay, this is the, they are checking out how to check the data. Okay. So now we start our HTTP invoker. Okay, right now everything is 0, 0. Everything is 0, 0. Okay, so I start from here. I start here. Okay, let's see here queue. Like how can we check the queue? I am not starting the HTTP invoker. I'll wait for the queue. Okay, because this one will be going to read the data. Okay, so here, uh, this is list queue. Okay, and here is a view. See, same data is coming, like similar way, the JSON data. If I copy this data, this is the JSON data. Okay, this is coming from the API. Okay, and this data is keep coming, continuously coming. Okay, real time data. Okay, so this data once comes. Okay, close this. So here data is still here. Okay, but still it has not reached to the SDFS. Okay, now I'm making it enable, because I kept it very simple flow, because I'm not doing any manipulation thing with the nifi. But nifi you can do a lot. You can do replace tags, splitting data, everything you can do with the nifi. Okay. Okay. So now the data even come to the Kafka topic also. I will show you the data has come to the Kafka topic. First, we see the data has come to the Hadoop file system. Okay. So we have already opened. Yeah, yeah. So we have to do Hadoop fsls command. Okay. So this is the JSON file data. So I want to do the cat command. Do fs minus cat. Okay. So these files are arrived here. Okay. So this data has come to the, up now we verify the data on the Kafka topic, because the, I have given here, if you see here, put SDFS. So here my property is desired. So till here I verified the data, right? I verified the data. Now if I come to the Kafka, so this Kafka processor, I drag here processor and publish Kafka. Okay. So I check the configuration. So here, what you need to set, you have to set your Kafka broker where you want to publish the data. So this processor, what is doing, it is reading the files from your Hadoop file system, and Kafka broker has a topic where it is writing the data, and the topic name is desired data CSV. So this topic is already present because this topic is already created in the, when we did the Docker compose. So here at the time of Kafka, so this Kafka setup is done right in the Zookeeper. So Zookeeper is needed. So Zookeeper is Kafka is depend on the Zookeeper. So first Zookeeper will be configured, and then Kafka will be configured in the our Docker Compose. So it is using 9092 is a default port. Okay, this is internal port and one is outer external port. Okay, and the topic I created manually. So we have to go to the Kafka cluster and then we can create a topic. So how to go to the Kafka container? So here the Kafka container is um, this one. So this is Hadoop Spark Hive. This is a Kafka. Okay. So okay, now I'm in the container. So I go to, this is a Kafka installation folder. So this way we are verifying the data is present or data has come or not. So this is Kafka console consumer.sh, and this is the particular topic I want to check data. Okay, because data is published on the topic, but I need to verify the data. So there is a command line consumer, we are checking it. So same data is published from the SDFS file, right? Hadoop file system. It has published to the Kafka topic. So pipeline, this nifi pipeline till here it is done. Okay. After this, the Spark job will come in picture, which is reading the data from this published Kafka topic. And once the data is processed by the Spark job, then it will be writing the data another Kafka topic. And from there, it will be writing data to the Hadoop file system. Okay. So here, so we have verified the data is present on the Kafka topic. Okay. How to run a Spark job. Okay. So now my data is on the, data is in the published Kafka topic. Okay. So this is my Spark job. Test.py. Okay. So this Spark job, this Spark job is using the structured streaming. So structured streaming is powerful than the D stream. D stream is a sequence of RDD, and structured streaming is a sequence of data frame. You guys getting my voice?
Yes, yes.
Okay. So structured streaming is more powerful than the, because the first of all, the structured streaming is supporting the watermarking. It is handling the delayed event. Like whenever the events are delaying, right, or your messages are delaying, right? So that cannot be handled in the D stream. And D stream is a sequence of RDD you have to use for each batch, for each RDD, and then you have to iterate RDD and doing the transformation. But the structured streaming, you are getting directly the data frame, but this data frame you cannot do any show because you have to write to the some write stream. Okay, so once you read a stream and you have to write to the write stream, then only you can. So you have to either use console or some, or you have to use some other like a target store. Either you can write the write stream data to the SQL DBs, no SQL DBs, or Kafka. So anywhere you can, or even the write the file, Parquet file, or any file format data. So you can write the stream. And once your stream is like, then after you can automatically it will show you the data. Okay, so you don't need to do manually data frame dot show. Okay, because once after your stream is write and then start, so read first and write and then you start. So in the write stream you have to do start, whether this write stream you are doing for Kafka format or console format or file format, any format. After that, once you start, so it will keep running. Okay, so it will be keep running, reading data parallelly from the source and writing data to the target. So what here we are doing, just simply here, I created a schema, and that schema is like a whatever the stream I read, right? So I'm reading from the particular Kafka topic and I'm giving my uh, subscribe the Kafka topic and Kafka broker, okay, server. And once I get the messages, and then I'm just doing the parsing of these messages. Okay, so if suppose I'm not doing those configuration, those data handling things I'm not doing in the nifi, right? Those replace text, splitting data. So I can read directly the as it is this JSON data, the same JSON data which I showed you. So this JSON data we can read, this JSON data we can read from the Kafka topic, and then we can do the flattening, right? We can use explode function. So we can apply splitting the data, and then we can replacing the text. So everything we can easily do in the Spark data transformation. So whenever any issue comes related to the transformation related, so you will look at your Spark code rather than the nifi configuration. Okay, because nifi configurations, like if you do a small mistake there, so it is very difficult to debug, or you cannot get the proper output, or you cannot exactly confirm it, like what input and output. So here in Spark, right, you can check the input and output, right? What input is there and what output you need, right? And what is the problem in your transformation, you can debug, right? Okay, so once this Spark job is writing data to the one consumer topic. So that consume topic, I give in a name desired output. And once the data comes on the consumer topic, then again the put SDFS is writing data to the file. Even I can directly write the data to the file, Hadoop file system. Even I don't need to use this entire thing, but I showed that how can we use the nifi consumer Kafka processor and put SDFS processor. If we don't want to use this flow, we can remove it and we can directly write the file to the Hadoop file system. Okay. And once the files are there, then our Airflow is reading those. Basically, it is not reading, it is a location, same location which of my Hive table location. So Hive table, there are two tables in the Hive is there. One is a raw table. Raw table is a Corona table, like which is my input data came. And this table is actually, now this data is coming in this particular staging location once after nifi is like a not processed, but raw data, it has manipulated, right? Like removing, like we have nested JSON data, right? So that nested JSON data, nested JSON, we are making it as a comma delimited character data, so that once the data comes as a comma delimited file, so I'm reading it. But if I have a JSON file, I can read directly the JSON file in the Hive also. So Hive is providing a JSON Saturday. So JSON Saturday, you can use here JSON Saturday and you can read the data in the Hive table. And another table is there, that is process data. So this file is also comma delimited character file, and which is coming from the Spark, right? Once the data is processed and then the data comes on the Hadoop file system. Okay, so this data is having only these many columns. So our analysis will be, the reporting will be done on these 4 columns, right? Country code, country name, how many death cases, and what is a time stamp is there. So that these are the main process data columns. Okay. So next is Spark job, how to run this Spark job. So first of all, for running a Spark job, so you know, right, Spark job will run in the Spark container. So you have to come to the Spark container. But before that, we are using Docker command to copy the our local home folder. This test py file is there. You remember, right? This Docker exp folder. And this is my EC2 user, right? My home user. And from there, I want to copy my Spark's my Spark application file, right? The name of the Spark application file. So there is a concept of Docker volume is there. So Docker volume is basically you can connect, like you can say, okay, I want to share my data from my local machine to the container, because you cannot directly copy paste, right? So you have to create a Docker volume. If you see here in the Docker compose, see here, all these volumes are there. So when I say volume means, like if I'm keeping it, my local folder is a Hadoop conf. So this will map to the OPT Hadoop 3.2.1 etc Hadoop. So my all configuration file like core site.xml, SDFS site.xml, I will create a folder Hadoop conf. So these files will be pointing out to the, so core site SDFS site.xml, that will be pointing to the container location. Okay, now let's see Spark container one. So what is the volume given there? So Spark is here, Spark master. So Spark volume is like Spark home. So my Spark home is like I'm mapping it to the /Spark. Okay. So this is my container location. Right side is the container location, and this is my local. Okay. So I'm just mapping to the /Spark. So when I go to the container, I have a Spark folder there. My test.py file will be there. Okay. So I will first go to my container. So I have to exit from this container because I'm already in the Kafka container. So I came out. Now I'm going to the Spark container. So here ls I do. So here you will see cd. Where it is copied. This is SDP Spark Master test py. Okay, okay, I have done this. Okay, so again I started. So I have to do this part first. Okay, it is not still copied. So I will exit. I will run this command first. So my EC2 folder docker exp, that file is there. Okay. Okay. Yeah, that file is there. That's the reason this file is copied. Okay. Now I go to the container. Yeah, test.py came. Okay. Actually, I want to show this will come directly there because I have not given any particular folder. If I say /opt/test.py, so where this file will go? In OPT folder will go. So you need to tell the mapping, right? Where you want to exactly copy the file. So you can copy the file in the container particular location. But I don't need anywhere. I want here itself. Okay, so test.py. And now I have to run the Spark job. Okay. So when I want to run the Spark job, so I have to give the permission to this one. Otherwise, I cannot do the execute permission. Okay. Okay. Now I will copy my Spark submit command. And this Spark submit command is taking the packages, okay? Because Spark streaming need a SQL Kafka, this package, right? So generally when we do Spark shell also, even PySpark shell or Scala shell, when we do, we need a package, right? So for the Spark submit also, we are giving package. So online, it will download it, this package, and use it as a jar, right? Otherwise, you will not get the you will not be able to read the data from the Kafka topic, okay? Because this Spark SQL streaming Kafka streaming jar, you need to either you can download it separately and keep it. You can provide minus minus jar option. So there are two ways. Either you can use minus minus package or you can use minus minus jar and you can give the local location of your place, okay, where you kept it jar. So now this is the Spark job. Okay, now we verify the Hadoop container again to check whether our output folder, the data came or not. Okay. Okay. We have not started the here. Okay. So here we have to start first because we have to consume the data from the Kafka topic. Okay. So here verify because our Spark job is running and here we should start getting the data. And then put SDFS is writing data to the Hadoop file system. My output SDFS folder where my process data will come. This is reading the data from this. This is a partition number 000. This is the partition. It is reading the data. Yeah, something came here, right? See, in and out. In is coming. Okay, in. Okay. So in means receiving and out means the writing. So put SDFS is again reading from the source and writing to the its target. Okay. So here if I see put SDFS configuration, so I will see desired data is my Hadoop directory. There is a desired Kafka output. So final data, process data, I'm writing to the desired Kafka output. Okay, in this directory. So this SDFS is basically writing data for the raw data, and this is writing the process data. Okay, so now Now I go to the Hadoop container and check the data, or even Kafka container, we can see the data, but final destination point, we have to see the data, right? Okay. So Hadoop container. Okay, I'm in the container, so we cannot start another container. Still it didn't come out. Is a Kafka. Okay, so these files came. Okay, now let's verify the data. This data is not actual process data, okay, because we have not done those splitting, all those things, okay, because we have removed that nifi flow, right? So this data you will look at, it's again JSON only, okay. So we have to do explode all those things and then make it more process data. So how do see, this is the JSON data, okay, but actual proof of concept, they are sending this data as a comma delimited, right? Like basically this data is present in this particular location, and from there the airflow is basically writing data to the Hive table, okay. So now next thing is how to use the airflow. So first we have to log in the airflow. So airflow is this is the URL for airflow, and the username password is airflow. Okay, so if you look at this airflow here, so if I want to use like, I need to make a connection. Suppose I want to read the file, okay, and write the data into Hive table, okay. But how to access the Hive, like how Airflow will get the access, okay. So there is admin and we can go to connection, okay. So we have to create a connection. So here this connection is like, if I show you the connection property, so this connection property is like, I have to choose the Hive client wrapper and Hive local and Hive server. The host is a Hive server, the container name, okay, and login is the Hive, and password is also Hive, and 10,000 is a default port, okay. So this is the configuration, and we have to create a one connection. And when the airflow job, how to check the airflow? So airflow script is there. So airflow script we can find here. So we have already in the beginning, you remember, right? We have copied the two files, right? One, the airflow script file for the Hive script, right? Like how to this airflow DAG. So airflow DAG is we define the airflow DAG, we define the Hive command to execute the Hive operator. Okay. This one. So this script file I copied there in the DAX folder. So anything you want to execute from the Airflow, you should copy that DAG file in the DAX folder. And this DAX folder, it will be created when it is installed. One DAG folder will be created, DAX folder. So this DAG folder you can see. So here is a DAX folder is there. So this DAX folder will come once your Airflow, like it is created by Docker, right? So that is the reason it is saying the name Docker. And when I go to in this DAX, so this any Python DAG file you want to execute it, get it executed from the Airflow. So you have to. So I copied this Hive connection also. So if you are not want to execute this Hive connection.py by Airflow, so you have to create manually. Otherwise, whenever you are copying this one, you can, whenever you copy this DAG files in the DAX folder, and your Airflow will automatically detect, right? And then it will, because this connection related thing, it will run automatically. Because what is this inside this connection? Create database if not exist. So you are creating a database and table, okay, and bash operator you are calling, and you are using Hive operator, okay. So here two tasks are there. One task is bash and one is Hive. Bash is basically just simple one bash command I'm running, nothing else. And this SQL query I'm running with the Hive operator, okay. So Hive operator is basically executing your Hive script task. So Hive script, either you can give this SQL query itself here, or you can give some file, SQL file. And that SQL file, you can give the path of the file in the, instead of CLI command. And it is using locally the connection, that Hive local connection. So this connection, it will read it through the configuration of the Airflow. Okay, it will find. If that connection is not there, it will say that connection is not found. And this job will run. Okay. So this is the DAG name is a Hive script. Okay. So I check there here Hive script. So this Hive script, I open this DAG. So this is now disabled. This is now disabled. And there are the two tasks you are able to see here, right? So when I enable this DAG and I want to start it. So I will trigger DAG. So when I trigger DAG, a new flow will start. So here first, there are the two tasks only. One is a bash that is just simply printing PWD or what we are doing in that. Just we are doing echo, who am I? Okay. So this is just simple bash command, or you can give the some shell script file also. So there the two ways are there. Either you can do bash command or Hive command, or you can give the particular file. So now you see this green color coding is showing like this is completed successfully. If it is running, it is light green. If it is yellow, means it's like uh, like again and again it is keep trying. I want to check the log of particular task operator. So I click on this and check the log. So particular task log I can see. So I printed the who am I. Okay. Mm, some username should come. Yeah, yeah, here. This is a bash command. Oh, output is not coming here. Command. The command didn't give any error code one. The my is a username. Okay, so another one is if we go to another task, okay, that is a Hive script one. So if we check here, so this is the script is running. So my DB. So how to check it? Like we go to the Hive container. Go to Hive container. This is a high container. So once I come to the container, I will start Hive. MyDB is created. I use the database MyDB and show tables and select test underscore. So this is the inserting some data. Okay. So whatever we given in the script, right, that is writing the data. So here value 2, we are writing the value 2. So this we run it through the, so similar way, like whatever process data came, so we can create the table script, like same table script. This table script you can copy paste in the Airflow DAG, or you can give a separate HQL file. You can give the path of this HQL file, this process data one, this one. So this file you can give the, and the, already your desired Kafka output location, your file is already present. So, but that file is still JSON, right? Because it's not a process file, right? It is not a comma delimited. It's a JSON file. So either if you use JSON Saturday you use, then only you can do, or you can flatten data. You can convert the JSON to the CSV in the Spark job. Okay, and then write the data. Okay, on the Kafka topic. So then Kafka topic will write the file as a comma delimited file. So this way we can create a task in the Airflow, the Hive operator task. Similar way we can do the Spark operator, like Spark submit operator. So I want to run my Spark job with the Airflow. So I can create another task. Okay. So another Hive script, second version is there. This, so I can disable Hive script 2. This is only Hive script task. So if I want to see the code, you can click here, you can see the code. So you can see the script code. So this one is creating another table, Airflow Hive, and this create table, right? It is doing use default, and this is creating a table and inserting data. So this one is only one task is there. So we can trigger that. Okay, we have to enable that. So what are the components are used here? Till here it is so whatever this invoke std update attribute, add timestamp, so these things we have not done. We have directly published Kafka, and consume Kafka is reading data from the Kafka topic and process. And after writing this pushed as SDFS, and from there, these are the external table location, and Airflow is basically reading data from the SDFS and writing to the Hive table. Okay, because it's just table mapping. Okay, and then we can do the quick cite and Tableau to visualize the data. Okay, so you can go through it, like what are the component, like we can have Flume is similar to Kafka. Okay, but Flume is not is a part of the Hadoop ecosystem component. So you have a dependency of the Hadoop file system and the Flume. The Flume is having the source, sink, and channel. So source is getting like from the place from where you are getting the data, and channel is a medium. It is flowing the data, and target is a sink, right? Where is your data is you are writing. So generally we use SDFS sync in case of Flume. Suppose I'm reading a data from Kafka, Twitter, or any other external source and write the data to the Hadoop file system. So instead of nifi, we can use Flume as well, right? I can read my files from Hadoop file system and uh, read files from the external places, or I can read data from Kafka also in Flume also. So Kafka with Flume integration also there. So, and Flume is having the Kafka sync also. Okay. So these are the like a high Presto and Druid. Okay. So these are the difference they told about, but we use Hive. Okay. Here we use Kafka. Here we use Hive. Okay. So these are the Druid is the like a columnar oriented open source tool. Okay. But mostly we are using Hive as a data warehouse tool and for SQL queries and optimize for the query throughput. But Presto is another tool as a client tool which can access the data from Hive, and it is similar to the Impala. So Impala, we know it's a in-memory management, right? It is not converting query into the Hadoop MapReduce, right? So Presto and Impala, similar kind of tool. These are like directly read the data without converting the MapReduce. And Spark is a processing engine, right? It's processing the data. There are the various transformation, core and core transformations are there. Map, flat map, filter, join. So a lot of transformations we can do. So we can leverage whatever nifi is doing. The same thing we can do in the Spark job. We can write our JSON data processing or and any other SQL, NoSQL, or any stream processing source, we can read the data. Spark has the integration with the various tools, Kafka, Cassandra, Mongo, and Elasticsearch, Snowflake, right? So anywhere we can read the data in the Spark. Okay. And here the comparison of the Airflow and Oozie. Oozie is again part of Hadoop ecosystem component. Okay. It is tightly coupled with the Hadoop. So you need installation of Oozie on top of the Hadoop file system. So, but Airflow is open source tool. You can use it, Airflow, for any type of job, even Java or um, any type of job. You can Hive, Scoop. So there are the different types of operators are there. So you can create even the entire pipeline using the Airflow. But Airflow is just providing the orchestration. It is not providing any storage or any processing. Its on processing layer is not there. It is just providing the orchestration. So if I say I have a data in Hive and I want to read data from Hive, so I will use Hive operator. And once I get the process the Hive task, and then I say my data, um, suppose I created table and I loaded data. Once my this Hive task is done, I say my Spark submit operator I am calling. So actually I can keep it in the Airflow. I can define in my DAG, right? So I can define in my DAG. First I say Hive operator. So this Hive operator is nothing but a Hive task. And this Hive task may be creating a table and loading a data. Okay. And loading data, some files or some anywhere else. Okay. So this is complete one task. Okay. Loading data into Hive table. Then I say, once my data is there in Hive, I want to call my Spark submit operator. It is nothing but a Spark job. And this Spark task or Spark job is reading the Hive table, populated Hive table, reading Hive tables, and doing the transformation. So I will get a data frame. We know whenever we are reading data from any file system, SQL, NoSQL, or streaming, we get the data as a streaming, get the data as a data frame. And once the data is data frame, then we can do transformations. Okay. So transformation, validation. So before transformation also we can do validation check. So in our pipeline, we can define some validation check is there, like data type casting check is there. Like we want to check whether the data type is valid or not. So data type casting check. And some more check is there, like data type and the record count validation, duplicate record count validation, and null value, missing value. Okay. So those checks we can put it. And some business validation we can apply. Business validation is like, okay, I say this particular column has the list data. Okay. One particular column is I say country. Okay. Selected country. So when I say selected country, I say I want to allow only these two countries, US, India. Okay. So I should not allow any other value than these two countries. So this kind of validations are called business validation, like list validations, like content validation, right? So I can apply these validations like through the Spark data frame. I can check is in operator is there, right? Is in, and then I can say list, right? So I can say df dot is in. So this way we can define our validations. These are called business validation. These are not data validation. So these are the business validation on data. Okay. So this one is initially the data checking validations, right? We are checking the data is valid type or missing data, null data, those we are filtering data, right? And if any kind of this kind of data is we found, we are writing this data to the error table. We are defining some error table. Okay. So this we can write it any SQL DB or Hive or any file system, anywhere we can write it. So I'm deciding, right, this error table, and I'm keep writing the data based on the daily basis load, so that I can confirm to my stakeholders, right? Okay, what data they are sending from the source team. I can report them that this data is not valid data type or valid data. The data is missing. Okay, so they can correct the data. Business validation is once this validation checks are done, then we apply the business validation. It could be anything. It could be list validation or any particular criteria condition, right? Case and when condition can be there. So some case and when conditions can be apply. Okay, we can do, or some UDF functions we can do also. Suppose the entire column, data frame column, right? I want to apply validations, right? So I can use the UDF. So there are the multiple ways to do the business validation, and then we apply the our transformations. The transformations, like maybe the data is coming from the two different data sets. So we can do the join, we can do, okay, so join is basically aggregating the data, like combining data using columns, combining data of two sets using uh, total number of column. Okay. But if I say I want to combine the rows, right? So we do union, right? Or union all, right? So union on union all, like we can do combining data on rows, right? But for this, the schema should be same, right? The valid condition is, otherwise union will not trigger. Okay. So the number of column type and number of columns same. The number of columns and type should match. Okay. So this Spark can do whatever processing you can do. And finally, you define your writing part, right? You define writing data. So this you can choose depend on the which type of processing you are doing. Either you are doing a batch processing or you are doing real-time processing. So real-time processing, generally real-time sources, right? Or targets we define. So Kafka is one. Okay. And we can say file system could be also the real-time data we can write. So in the particular location, you will keep writing the files, right? Okay. And some other downstream job will be keep reading your data. Okay. Or you can say you can write in the data in the SQL database table. Okay. Or you can say no SQL table. So it could be any, but batch is Kafka will not be there. Okay. So Kafka will not be there, but other batch sources are there like file system, SQL databases. Okay. So those sources you can write it data into the batch. So you have to check what type of processing you are doing. So there are the two architecture you can go through it, Lambda architecture and one is the Kappa architecture. Okay. So one architecture is having the combination of your batch and real-time processing both. Okay. In the Kappa architecture, you have both streaming plus batch, and one is only streaming. So when you say the data is initially coming streaming, data is initially coming is a streaming, but when it is processing, it is in the batches, and then finally you are writing the data into batches. So that combination is called stream plus batch. Okay. So we can decide that one. Okay. And Spark can do, and Spark is maintained the DAG, direct cyclic graph, and the RDD lineage is there, right? That is maintaining the. So what is the fault tolerance in Spark? So fault tolerance in the Spark is like if your any is computation is failed, right? So it can recompute, right? It will, and you have seen it is using some cache, right? Suppose sometimes you are doing a list of operations and in middle of the operation got failed. So it should not the start from the scratch. So you can do the RDD or data frame cache so that it can be uh, like it cannot do the entire recomputation. So it can start from there, it got failed. Okay, so it will get the data from the cache. Okay, so go through it. Okay, and first you set up your and better is another way that I told, uh, the on premises one, right? Like basically you can set up your Ubuntu virtual box. So set up your virtual box and install all those 6 7 6 components. All those you install, like Hadoop you install, Spark you install. Okay, and nifi you install. So nifi you can directly download, it's a zip, and then extract it, and then you start nifi start. So nifi hyphen start dot sh. So you can start your nifi server, and then you can see the UI. Okay, so that is basically. So this way you can do all the installation first. NiFi, Airflow also you can do in the Ubuntu, and Kafka also. It's a zip, right? You can install, download zip, and then you can. It will take time, but it is once, right, you set up, right, you can run any number of pipelines you can run. Okay, and Hadoop, Spark, NiFi, Airflow, Kafka. Okay, so these all things once installed, and the same configuration things you follow, like same, like once your air this nifi comes, so you can create so first you start with the nifi, and then you create a flow. Okay, and this flow will pushing the data to the getting data from the api and writing to the sdfs and writing to the kafka topic. Then your spark will come in picture, and then spark will be processing the data. So transformations layer we have to work a lot, because here is nothing, because if we are not using the nifi related processor, so we have to write code, we have to change the code here. So this one here we have to, like each and every step, right? Once we get the data from the Kafka topic, it's a JSON data, we have to flatten data, and then we have to, um, so grouping data also they are doing. Okay, so once we have the data, then we are doing the grouping, because we have to aggregate the data based on the country, right? So we want to grouping the data, and here is not much more transformation we did, just grouping we did, and then we have converted. Okay, suppose we are just doing to JSON, like from JSON to get the JSON data. And if you want to write JSON, then to JSON is there. Okay. Or simply this data frame, if I want to write as is, I want to write as a file. So directly I can write data frame dot write, I can write as a file. Okay. But I want to write as a JSON to the Kafka topic. And from Kafka topic, again, I'm converting into CSV in the using nifi. So instead of that, rather than giving the task to the nifi, I can directly this data frame I can write it, because this is after grouping this data frame you can write as a csv. So you can make it here, write stream format csv, and you can write or the data from write stream, you can write a file type. Okay, so when you are format file, so your file, if it is um, this is a data frame, and then you can write as a CSV file format. By default file format CSV or Parquet file format it will write. Okay, if you are not specifying any particular format. Okay. Okay, I'll share this code and everything. Anyone has any questions can ask me. Okay. So, and this is the website link. You can see here all the steps, like whatever the steps we follow. Okay, like NiFi real time, this NiFi part, this is the Kafka part, and data cleansing, transformation, storing. Okay, and the Airflow, and this is the Tableau or QuickSight. Okay, I haven't checked the QuickSight. So QuickSight is the visualization tool. QuickSight. Okay, it is a paid one. So here the free or this is some trial. Okay, so it is. It's a complete account process. Okay. Actually, it's a part of AWS, but it is taking it to the another interface of the AWS. Okay. So, and you guys can take the credit also. So AWS free credit is there. Okay. So you can use a $300 free credit from the Medium link. So you can just talk about your PSC you tell, then you will get the free 300 credit for 6 months. This one. So this link I'm giving to you, this link here, you can just go to this link and fill this form and say here like your existing account, your account ID and those things. And then you can say about your POC and those information you fill. So here you say this is a proof of concept and time frame you say 4 to 6 months. Budget range you say 100 to 499 you say, so you will get 300. And here you can say some analytics, big data analytics related. Company name, you can give company name, and but here you can use your Gmail ID. It's not mandatory you should have any business email. You can use your personal Gmail ID. Your account should have, you should have your own account ID. Then only you can credit in your account. Okay, so any existing account. And you fill this form and personal interest you say, and they will validate to 3 to 5 days, for business days, and then they will update your credit. So how will you see the credit? You go to your account once you can verify. So when you, so here, when you go to, there is a credit billing dashboard, you go here. Here is a credit, you can see. So like this credit will come. Okay. So like this credit will come, right? So I'm using the, my, I have 3 different credits. So I'm using that way. So you can get the credit. Okay. And every, so the bill will be deducted from your credit. Okay. Any bill you will be doing. So you can check your bill here regularly. So you can, so stop the, we can do for any data, right? Grouping we can do. It's a data frame grouping we are doing. So whether it's a batch data, the only difference is if you are doing the grouping on the streaming data, we have to run inside the for each batch. Okay. So whenever one batch of the data will come in the streaming, then we will be running inside the batch. Okay. So that grouping we can do. So it's a data frame grouping. So we can do. So, so you can check your bills, right? Or so main important thing is you can, your instances, you should, if you are not using the instances, you just stop it. Okay. But at least your bill will not be there if the instance is continuously running. So only the storage charge will be there. That is EBS volume charge. And that is very low, just $2 a month. Okay. So that's just, even your instance is stopped, but not being run. Okay. Okay, thanks everyone. And I'll share the recording. Okay, so I'll share the recording. You can see, and I will share the this code and everything, so you can practice. Okay, thank you.
Thanks.